Hi, good evening dear students. Welcome back to second PUC online classes. In last class, we learned about the Rutherford alpha particle experiment and its observations. In today's class, I am going to explain about the impact parameter and distance of a closest approach and derivation of a total energy of electron in terms of orbit radius in an hydrogen atom using the Rutherford atomic model. Okay, this one is a very important concept for 2 marks. Impact parameter. Impact parameter is the important concept. Define impact parameter ಅಂತ ಕೇಳ್ತಾರೆ. impact parameter 2 marks question. What is impact parameter? Define impact parameter ಅಂತ ಕೇಳ್ತಾರೆ. definition it is the perpendicular distance between perpendicular distance between the initial velocity vector of the alpha particle, the initial velocity vector of the alpha particle and the center of the nucleus center of the nucleus. This one is a very important for 2 marks. It is the perpendicular distance between initial velocity vector of the alpha particle and the center of the nucleus. Already know, by using that Rutherford alpha particle experiment, we concluded that when that alpha particle away from the nucleus, it will be move straight line without deviating because of less repulsive force will be acting. When it is alpha particle comes near to the nucleus, it will be scattered more angle because of a repulsive force between alpha particle and the nucleus. Okay, here I will show the diagram. This one is one nucleus. Okay, this one is a nucleus charge positive. These are the alpha particles empty from the source. When this one alpha particle far away from the nucleus, okay, these are we call as alpha particle. This one alpha particle away from the nucleus means it will be move straight without any deviating, without any bending. It will be move straight line because alpha particle and nucleus between them force is very large. Very large means here due to that one it will be move, distance will be very large and the repulsive force will be very less. Due to that one it will be move along straight. When that alpha particle distance less, when it is move near to the nucleus, when that move near to the nucleus, the force between them is very large. Due to that one it will be scattered different direction. Here same, this one alpha particle is nearer to the nucleus means it will be scattered at more angle. And it is very away from the nucleus means it will be less repulsive force will be acting. Due to that one it will move along straight. Okay, and this one is the center of the nucleus. Okay, this line you call as center of the nucleus. For example, when alpha particles moving for head-on collision, due to that one, this one alpha particles move nearer to the nucleus, it comes to a rest, again it retreats back because between them here more repulsive force will be acting. Okay, between them, that more repulsive force will be acting. Due to this one, that the kinetic energy of alpha particle comes to rest. When it comes to rest means it converts like a potential energy and returns back. Okay, this one distance you call as velocity vector of an alpha particle. Velocity vector of alpha particle, and this one you call as center of the nucleus. Between them, this one you call as impact parameter. That impact parameter denoted by symbol B. Impact parameter denoted by symbol B. It is the perpendicular distance. This one is a perpendicular distance between initial velocity vector of an alpha particle and the center of the nucleus. This one distance we call as impact parameter. Impact parameter. Its expression B is equal to, impact parameter B is equal to 1 divided by 4 pi epsilon naught. Epsilon naught Z E square cot theta divided by 2 divided by kinetic energy. This one you call as expression for the impact parameter. ಇದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಇಂಪ್ಯಾಕ್ಟ್ ಪ್ಯಾರಾಮೀಟರ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಫಾರ್ ಅನ್ ಎಡಾನ್ ಕೊಲಿಷನ್ ಅಂತಂದವಾಗ that alpha particles move towards the nucleus, it comes to rest, again returns back. This one you call as head-on collision. For that head-on collision, what is the scattering for impact parameter means? It is the angle 180 degree. It returns back means it's angle 180 degree. Then next one is the distance of closest approach. Next one concept. Distance of closest approach denoted by symbol R naught. Distance of a closest approach. It means when that alpha particle move towards the nucleus, the kinetic energy of this one alpha particles converts to potential energy. When it comes to potential energy means it comes to rest. Again it returns back in the same direction. Okay, this distance we call as distance of closest approach denoted by symbol R naught. Definition: the minimum distance up to which an energetic alpha particle traveling directly towards a nucleus can move before coming to rest, and then retracing nothing but retracing its path. Its path is known as distance of closest approach. Distance of closest approach denoted by symbol R naught. So here this one you call as nucleus. This one is the nucleus, and this one is an alpha particle. Alpha particle move towards the nucleus. Okay, this one you call as alpha particle move towards the nucleus. This kinetic energy of alpha particle converts to potential energy when it comes nearer to the nucleus. Why it comes to rest means between them more repulsive force will be acting. Okay, here converts to potential energy. its distance between them is considered as an R naught. R naught we call as distance approach. Here it converts to potential energy. Kinetic energy converts to potential energy. Then it will be retreats back in the same direction. When it retreats back in the same direction means angle between them it is in 180 degree. For that 180 degree, your impact parameter B is equal to value will be 0. Okay, this distance we call as R naught. R naught means distance of a closest approach. Definition, the minimum distance up to which the energetic alpha particle traveling directly towards a nucleus can move before coming to rest, and the retracing its path is known as distance of a closest approach. Here this one minimum distance you call as the distance of a closest approach, and its expression R naught is equal to its expression here kinetic energy converts to potential energy. According to the definition, kinetic energy converts to electrostatic potential energy. Electrostatic potential energy. What is the formula for that kinetic energy? Half into m into v square. Electrostatic potential energy 1 divided by 4 pi epsilon naught Ze. It is the charge of nucleus, and 2e it is the charge of an alpha particle, divided by R naught. Okay, because this one we are using electrostatic potential energy formula. Okay, EP is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R. Then therefore the distance of closest approach R naught is equal to, we have to find out R naught, distance of closest approach. R naught is equal to 1 divided by 4 pi epsilon naught 2 Z into E square divided by 1 divided by 2 M into V square. 1 divided by E square. Then R naught is equal to 1 divided by 4 pi epsilon naught 2 Z into E square divided by kinetic energy. Okay, this one you call as final expression of the distance of a closest approach. Okay, some questions will be discussing regarding the impact parameter and the distance of closest approach. Question number 1. What is the angle? What is the angle of a scattering? What is the angle of a scattering for impact parameter is B is equal to 0. B is equal to 0, nothing but the direction of alpha particle move towards the nucleus. It comes to rest position, again retreats back in the same direction. Here perpendicular distance and a returning line, that two are same. Means B is equal to 0. B is equal to 0 means angle between them it is an 180 degree. Its answer 180 degree. Next question. Question number 2. What is the significance of the impact parameter? This one is important question. What is the significance of the impact parameter? Answer: when impact parameter is small, when impact parameter is small, the scattering angle is large. The scattering angle is large. because electrostatic repulsive force is large. Repulsive force is large. It means this one is a, when you consider as a nucleus, this one is alpha particle. When alpha particle nearer to the nucleus, distance between them is very small, and due to this one, more repulsive force will be acting. It will be scattered at more angle. Okay, when it is away from the nucleus means less repulsive force will be acting, it will be scattered less angle or without deviating move along a straight. Okay, this one you call as significance of the impact parameter. When parameter is small, means distance between center of the nucleus and velocity vector of an alpha particle. This one distance small means here repulsive force will be large. Okay, up to here 2 concepts over. Thank you.